Welcome! So in this video, I'm going to talk about how to do the permutations of arranging four objects and how that relates to the brute force method if you're doing something like a Hamilton circuit and you want to figure out which circuit is going to give you the optimal solution. So here I have 5 cities. We got Las Vegas, Aspen, Bora Bora, Capri, and Dubai. And let's say you want to go to all 5 of these cities. I'm currently in Las Vegas, so I'm going to assume this is going to be my starting point. But remember, if you're doing like the repetitive nearest neighbor method, that you're going to check all 5 of these. The first thing you want to do is do a complete graph. So each of these is going to be connected. But in addition, each of these is also going to be connected to each other. So for example, Las Vegas is also connected to Bora Bora and Capri. Aspen is already connected to Las Vegas and Bora Bora, but it's also going to be connected to Capri and Dubai. It looks like Capri is done. Dubai is going to be connected to Bora Bora. And I think we are there. So you should have a total of 10 edges if you have 5 cities you want to go to. And if you notice, if I fix this one a little bit, you sort of get a star pattern. All right, so what you want to do is, for the brute force method, you want to arrange the 4 cities that aren't your start and stop location. So for me, my starting and stop location is Las Vegas, and then we're going to arrange these other 4 cities. When you do that, that's called doing a permutation. So we're going to find the permutation of all 4 of these cities, which is going to be 24 different things we have to look at. So again, Las Vegas is not going to be part of that permutation. It's our starting and stopping, and that's set. But these other 4 options, you can do what's called 4 factorial, which is the same thing as 4 That's going to be the same thing as 4 times 3 times 2 times 1. If you multiply this out, you're going to get 24, and that tells us the 24 different permutations we have to look at. All right, so give me a minute to get situated, and I will show you how to calculate those 24 permutations. Okay, so I labeled, or I made a table of 24 different options, and I purposely chose cities that go in alphabetical order. So I got A for Aspen, B for Bora Bora, C for Capri, D for Dubai, and my 2, Las Vegas. My starting and ending location, we're going to worry about these in a minute. I'm going to put them off to the side for right now. Well, the first option we have is to go directly in alphabetical order. So we could say A, B, C, D. Now here's what I like to do. I like to set up a pattern. For my next option, all I'm going to do is switch these two around. So that's going to give me A, B, D, C. Alright, so we can't switch these around anymore because there would just be the first 2 options already. So what we have to do is we now have to go to this 3rd one and switch it around. So I'm going to switch. If this is option 1, 2, 3, and 4, I'm going to switch 2 and 3 around. That will give us A, C, B, D. Then I'm going to switch these 2 around. A, C, D, B. There's no more options for Aspen and then Capri. So let's put these back in order. So now I'm going to put D in the 2nd spot. So now we got Aspen, Dubai, Bora Bora, and Capri. So that would be A, D, B, C. And then switch the last 2. So A, D, C, B. Now if you notice, all of these are leading with A, and there should be 6 of them. If you notice, 6 is exactly 1/4 of 24, which makes sense. 6 of my 24 options are going to start with A, 6 of the 24 options are going to start with B, 6 with C, and 6 with D. So there's nothing more we can do with A that hasn't already been done. We've done all the permutations with A coming first. So now what we're going to do is put B in spot 1. I like to keep these in alphabetical order as much as possible. So I have a new spot 1, spot 2, 3, and 4. I'm going to have in the most alphabetical order as I can, so A, C, D. So this will give me B, A, C, D. You guessed it, switch spots 2 and 3. I'm sorry, 3 and 4. So B, A, D, C. I've gone as far as I can with A in spot 2. I'm still keeping B in spot 1, but I have to move something else into spot 2 to get the remaining permutations. So again, go in alphabetical order. I will move C into spot 2, and then I got AD. So B, C, AD. Switch spots 3 and 4. BCDA. That is as far as I can go with C in spot 2. So finally, I'm going to put D in spot 2. And then notice I try to keep these in alphabetical order as much as possible. So now we have B, D, A, C. And the last one I'm going to do is switch spots 3 and 4. B, D, C, A. So now we're halfway done. We've done all the options with A in the front. We did all the options with B in the front. So now we're going to do the options with C in spot number 1. So again, whenever I move something into a higher spot, I like to go back to alphabetical order as much as possible. So now we have C, A, B, D. Switch spots 3 and 4. C, A, D, B. That's as far as I can go with A in spot 2. So when I move something to a higher spot, go back to alphabetical order as much as possible. C, B, A, D. And then switch the last 2 around. C, B, D, A. Finally, I need to put D in spot 2. So I have C, D, A, B. Switch the last 2 spots, C, D, B, A. Notice we're now up to 18. So we're 3/4 of the way done. So finally, D is going to spot 1. Everything past the one you just changed, go back to alphabetical order. D, A, B, C. Switch spots 3 and 4. D, A, C, B. B now goes in spot 2. D, B, A, C. Switch spots 3 and 4. D, B, C, A. All right, that's as far as we can go with B in spot 2. 3, C goes into spot 2. D, C, A, B. And then look what happens when we do the last spot. We switch these 3 and 4 around one last time, and we have exactly reverse alphabetical order. D, C, B, A. That's always going to happen when you do your permutations. Your first one and last one are going to be exact opposites. And in fact, you should notice a pattern going around here that every one of these should have an opposite over here somewhere. If you're only worried about the permutations, you're done. You have all 24 permutations for arranging 4 objects. Now, if you're in graph theory, there's one more thing we have to do. So we have to assume that we're starting off in Las Vegas and we're ending in Las Vegas. So for example, if we look at our last permutation, the DCBA, well, we're actually not starting in Dubai, and we're actually not ending in Aspen. We're starting in Las Vegas, then going to Dubai, Capri, Bora Bora, Aspen, and then back home to Las Vegas. So remember, we have to complete a circuit. So this L is technically the same as this L. So we can kind of get rid of him and put these more in a circle if you like. So what we're really doing is Las Vegas to Dubai, Dubai to Bora Bora, Bora Bora to Aspen, Aspen to Capri, Capri back to Las Vegas, and that could be one of your permutations. Here's the full set again. So if you want to, we'll get rid of these numberings to make room. If you have room already, you don't have to erase these, but I ran out of room. So we're going to start in Las Vegas, end in Las Vegas for each of these. If you want the very last option, there you go. So Las Vegas, Dubai. So if you want the very last option, we have Las Vegas, Dubai, Capri, Bora Bora, Aspen, and then back to Las Vegas. This makes a complete circuit. So what we have here is we have a Hamilton circuit. We did every city exactly once. And the full list of permutations starting and stopping in Las Vegas.